So let's go ahead and take a look at the example about similar figures. We can see here that there are rectangles FJ, FG, HI, and JKLM are similar. What is the length of side JM? Well, since we use rubies to solve every problem, we're going to go ahead and write it here. RUBIES to remind us that we're going to read twice. So I'm going to go ahead and read twice, and this time I'm going to underline my important words in box numbers. Rectangles FGHI and JKLM are similar. What is the length of side JM? And so when we look at the first part of this, as we think it through, we can see it says which side corresponds to JM. Well, I'm going to identify JM by drawing a little oval around it, and I'm going to look at its corresponding side. So I'm looking for the same side of the shape just on my other figure, and I see that it's going to be right here, and that's FI. So I'm looking at the corresponding side of FI. Well, I also want to know what is the length of that side, and I can see that the length of that side is right here, and the length of that side is 8 feet. I also see that it wants me to write a proportion to find the length of side JM. Well, it wants me to figure out this side, so I'm going to put a variable here, and then it also says that I can use a proportion, which I know is going to be two fractions that are equal to each other. Well, when I look at this, I can actually just look at my figures and see that there's already kind of a proportion being made here. So I'm going to make my proportion the same way that I see it here. Draw out my line, and I can see that I have sides FG on top. So I'm going to put side FG on top, and that corresponds to side JK. Then I see side FI, and that corresponds to side JM, as we found out earlier. Well, now I can go ahead and replace those with some numbers or the measurements that are actually given to me here. So when I look at FG, well, FG right here, I'm going to box FG, do the same thing with JK. And so FG is 15 feet, and that's going to be across from JK, which is 24 feet. And FG is over top of FI, which is 8 feet. And that corresponds, or is across from my variable for JM, what I'm looking for. So now I'm going to go ahead and cross multiply, put my wall up, and now I'm looking to see the things that I'm multiplying. Well, 15 and X are in the same circle, so they get multiplied. And then I have 24 and 8, and they're being multiplied. So let's go ahead and multiply 24 times 8 off to the side. Using my multiplication chart, 4 times 8 is 32, so I put my 2 down here, carry that 3, 2 times 8 is 16, plus 3 is 19, so I know that 192 is equal to 15x, and so if I divide both sides by 15 to get x by itself, or to isolate my variable, I'm going to get 192, and that's going to be divided by 15. 15 goes into 19 one time. 1 times 5 is 15. 1 times 15 is 15. I subtract, I'm left with 4. Then I bring down that 2. 15 goes into 42 2 times. That's going to bring me to 30. And I subtract again. When I subtract, I'm left with 12. Bring down that 0. And then 15 goes into 120. Well, I'm actually not sure how many times it goes in, but what I can do is create a chart to figure it out. So I'm going to start right here at 1 and 15, then 2 and 30, just adding 15 again. So 3, adding 15 again gives me 45. 4, add 15 again is going to give me 60. I'm going to add it again, and I'm just going to keep going down and down until I can get as close as possible to 120. So I'm at 7, and that brings me to 105. And then finally, if I multiply 8 times 15, that will get me to 120. So I know that it's going to go into it 8 times. Well, 8 times 15, I just figured out is 120. So I'm going to subtract, left with 0. So I know now that the measurement of side JM is going to be equal to 12 and 8/10 feet. 12 and 8/10 feet. Why don't you go ahead and give it a try on your problem?